This is Geometry's Practice Test 9. All right, number 1. Got to name each of these figures. So number 1 is clearly a prism. I can tell that because the top here is the same shape as the bottom. The two faces adjacent to each other are the same. Therefore, it's a prism. And what is that base shape? It's a triangle. So it's a triangular prism. This next one, they meet at a point, therefore it's a pyramid. And that base shape has 1, 2, 3, 4, 5, 6 sides, so it's a hexagonal pyramid. All right, number 3, we're trying to find the volume of each of the figures. So in general, to find the volume, it's always going to be the base area times the height. This first one is a little bit tricky though, because the base area is hard to see. The base area here is actually the front, which is a trapezoid. So to find the area of a trapezoid, I know that if I have a trapezoid like so, and I call this one base 1 and base 2, and I have the height here, it's going to be, the area is going to be, I add the base 1 and base 2 together, and I divide that by 2 and multiply by the height. That'll be my area. So in this case, my area is going to be the tiny base is 5, the longer base is 11. It's kind of hard to see, but look, this length is 5. This length right here is the same length as this length right here, which is 11. So 5 plus 11. Then we're going to divide that by 2, and then we're going to multiply by the height. The height here, it says, is 5.2 for that length, so we're going to multiply by 5.2. I have the ability to use a calculator, so we might as well do that. Let's get my scientific calculator up here. There you go. So I'm going to do 5 plus 11, and then that whole entire thing, put parentheses, divided by 2, and then we're going to multiply by 5.2. And that area here is going to be 41.6. So that's the base area. So this base area is 41.6, and I need to multiply that by the height. The height in this case is this length coming out of the surface area, which is 6. So it's going to be multiplied by 6. So I just need to multiply, let's say answer times 6, and we get 249.6. Our units here are going to be kilometers, and because we're in the third dimension, it's going to be kilometers cubed. And I do want to check my work. So 249.6 kilometers cubed. I did not get the right answer. That's not good. What did I mess up on? Number 3. 11 and 5. We divide that by 2. We multiply by the height of 5.2. That is the area. And we multiply by the height. Oh, the height is not 6. Haha, silly Mr. Sandell. I was like, this length right here is 6 because the 6 is right next to it. Well, 6 is that length right here, which we don't actually need. It's a red herring. This length is the same as this length, which is the same as this length, which is 12. So you, sir, are not a 6. You're a 12. Whoa, they're too big of a eraser. Multiply by 12 here, which means we really need to double this. So I'm going to multiply by 12. I get 499.2. Let's check. 499.2, I think that looked correct. There it is, 499.2 kilometers squared. All right, number 4. Pyramids always have this formula that's 1/3 of the base area times the height. So the base area here is kind of easy. It's going to be 11 times 10, so this is going to be 110. And then the height here is 7, so times 7 and times 1/3, and we're basically done. So I'm going to say 1/3, and then we're going to multiply that by 110, multiply that by 7, and we get 256.6 7, because we're rounding to the nearest hundredth, which is 2 decimal places. So our units here are going to be feet cubed, because we're talking about volume. Volume is in the third dimension. So 256.67. Let's check. 256.67 feet cubed. Very nice. Number 5. Again, it's kind of like this pyramid shape. So it's going to be 1/3 of the base area times the height. In this case, the base is a little bit hard. It's going to be pi r squared, and that's going to be pi times the radius, which is half of 20, 10 squared. So it's going to be 100 pi. The height here is going to just be 20, so my final answer is going to be multiplied by 20, multiplied by 1/3. My volume is going to be 1/3 times 100, times pi times 20. And I get, oh my goodness, is that right? That's a humongous number. We're going to go with it. 2094.3. Oh, that 9 gets rounded up, so 2.40. And then our units here are going to be feet cubed again. 2094, number 5. Number 5, 2094. Very nice. All right, we're moving on to number 6. We've got this hexagonal prism, and we're doing surface area. So the very first thing is I'm seeing this triangle here. I'm going to reroute the triangle. It has a dashed line. That's a 6.1 here. I know that this length 7 is the same length as this length and this length, so this is also 7. The area of a triangle is 1/2 the base times the height. So it's going to be 1/2 of the base, which is 7, times the height of 6.1. And I type u in. I'm going to say 0.5 instead of a half. And then times 7 times 6.1. And I get 21.35 for the area of the triangle. And how many of those triangles are there? Well, there's a total of, it's a hexagon, so there's 6 of those. So I'm going to say 6 times 21.35 is the area of my base. And I'm going to say answer, oops. So I'm going to say answer times 6, and that's going to be 128.1. And then I just need to multiply. Okay, so that's one of them, right? I'm thinking about surface area. I have 1 on the top, 1 on the bottom, for a total of 2 of those. So I have 2 of these 128.1s. And what about this shape right here? Well, it's a rectangle that is a length of 8 by 7, right? So this length is 8, this length is 8, therefore this square back here, or this rectangle, is an 8 by 7. So I have an 8 by 7 rectangle, and how many of those do I have? I have 6 of those. So if I add those together, I get the following. I have 2 of those 128.1s plus 6 of these 8 by 7s, and I get 592.2. Units here are going to be kilometers squared. Let's see, 592.2. 592.2. Very nice. Number 7. Again, we have a hexagon, so some more practice on how to do a hexagon. I'm seeing the triangle there, which I'm going to redraw right here. I have dotted lines, and this is going to be a height of 6.9. The base here is going to be 8, so the area of the triangle is 1/2 the base times the height, or 1/2 of 8 times 6.9. So coming over here to my calculator, I'm going to do 0.5 of 8 times 6.9, and I get 27.6. All right, how many of those triangles do we have? 6. So I'm going to say 6 times this 27.6 to find that base area. So I'm going to say answer times 6, and I get, that's 165.6. Excellent. So that's, I have 1 copy of that, so I have 1 copy of this 165.6, and then this next shape is just a triangle, and I have 6 of those. So I'm going to do 6 of those triangles. And what is that triangle? So this skinny looking triangle has a height of 13 right here, and it has a base of 8. Still the same base, right? 8. So this one is going to be 1/2 base times height, or 1/2 of 8 times 13. Half of 8 is 4. 4 times 13 is 52. Is that right? Just want to, my math is not working too great tonight. I'm pretty tired. It is 52, so this is going to be equal to 52. And I have 6 copies of that 52. I'm going to add those together. So I'm going to get, I'm just going to multiply that one. So I'm going to say answer times 6, and I'm going to add up the 165.6, and I get 477.6. Units here, kilometers, second dimension, because area is in the second dimension. 477.6 for number 7, 477.6 for number 7. All right, moving on to number 8. 8 is notoriously difficult. You can just use the formula if you'd like. I'm going to rederive everything, but I can show you the shortcut right now because I'm sure that's what you're asking for. we're going to say that this length right here is called a slant height, which we usually do a cursive L for, and this is going to be radius. The general formula for the surface area of a cone is you do pi RL. That'll be the surface area of the lateral, this piece right there, and then you add that with the circle area, which is just pi r squared, pi r squared. So that's a shortcut. But where does that come from? Because that's more important, right? So making sure you understand this one. We have a circle, and we have this fan shape that is really going to be folded over together. The important thing to note is that the circumference of the circle is the same distance from here rolling down to here. It's the same distance. So to find this, I'm going to highlight this distance in green maybe. This distance right here is going to be, let's see, this is the radius. That distance is going to, this green highlight distance is 2 pi r. But if I were to look at the entire circle, then I need to say the entire circle would have been 2, oh, I don't want to write with that though, is going to be 2 pi l. And what I want to do is I want to find the percent of this area from the entire circle. So to find the percent of that area, I'm going to divide the little bit of piece over the entire piece. That'll be the percent. So this is equal to the percent. And you'll notice in here the 2 pi's cancel out, which means that the percent is just r divided by l. So now I'm going to go ahead and do all the areas, right? The area of this circle is pi r squared, and r in this case is l, so it's really pi l squared. So I'm going to multiply the area is going to be the percent times pi l squared. Well, if I'm being, here I'll say, yeah, no, that's fine. We'll say pi l squared, which is going to be r over l, which is the percent, times pi l squared. And notice what cancels out here. The l, one copy gets rid of, one copy gets rid of. And this is going to be r times l times pi, which is exactly what I said over here. R times l times pi. And then to find the area of that circle, it's just pi r squared. So I've re-derived everything, and we can now plug into our formula. This is going to be pi times r, which is 9, times l, which is 20.1. L stands for slant height. I just don't want to do an s because my 5's and s's look too similar. Plus pi times 9 squared. Just type this in, and we're done. All right, we get pi times 9 times 20.1, 20.1. And we're going to add that with pi times 9 squared. And I get 822.78 units right here are going to be inches squared. 822.78 for number 8. 822.78 for number 8. Nice. Number 9. Just identify the solid. So you can see that these will all come to a point at the very top. Therefore, it's a pyramid. Pyramid. What type of pyramid? Well, the base is a rectangle, so it's a rectangular pyramid. Number 10, it looks like a circle in a fan shape, therefore that is a cone. Number 11, use information given to find the scale factor. Okay, so scale factor, we have a calculator to help us out. We essentially just do the right divided by the left. You always do right divided by left. Right, I guess it goes left to right is our scale factor. I'm just going to do that on the calculator. So it's going to be 64 pi on the top. I'm going to divide that by 36 pi on the bottom. And that fraction is going to turn into, so I'll say, I want to show my work though. 64 pi over 36 pi reduces to 16 over 9, which means, and we're in surface area land. So surface area means that the ratio is squares. So to undo the square, we're going to square root it. So the square root at the top, square at the bottom, is going to be 4/3. So our ratio is 3 to 4. So number 11, 3 to 4. 11, 3 to 4. Excellent. Number 12, kind of similar, but volume is in the third dimension. So instead of doing a square root here, we're going to do a cube root. So again, I'm going to do this number divided by this number on my calculator for it to automatically reduce. I'll write out my work. So I'm going to do 1715 divided by 2560. What does that reduce to? 1715 divided by 2560, and you get this fraction that is 343 over 512, and then from there we need to cube root both the numerator and the denominator. All right, so I'll say that the cube root of 343 is 7, and the cube root of 512 is 8. So that means my scale factor, again, this went bigger to smaller, so I should go bigger to smaller, right? So I should say 8 to 7. So number 12 should be 8 to 7. Number 12 is 8 to 7. All right, number 13. Okay, find the surface area and the volume of the larger figure. Okay, so to get surface area, I'm just going to multiply by 4/3. To get the volume, I'm going to multiply by 4/3. The only difference is this one is going to be to the power of 2 because surface area is in the second dimension, and this volume is going to be to the power of 3 because it's in the third dimension. So let me just type those in, right? So I'm going to say 468 times this fraction of 4/3. This 4/3 is going to be just the 4/3, please. Just the 4/3 is going to be to the power of 2. And my answer is going to be 832 units kilometers squared. And then what about down here? I have 1728, and that's going to be multiplied by that same fraction 4/3. And that 4/3, I don't have to have parentheses, by the way. I can just say to the power of 3, and it'll work to the power of 3. And I get 4,096, and that's going to be kilometers cubed. So 8324096, and is that somewhere? 8324096. So we got both those correct. Moving on to the second last problem. Whoa. There we go. Number 14, we need to find the missing value. So we have a lot of steps on this one. We need to figure out what the ratio is. So I'm going to do this fraction of 45 over 20. Calculator can reduce that for us. So 45 divided by 20, and that's going to be this fraction of 9/4. And then because this is surface area land, that means we squared our ratio to get the current ratio. To undo that, we're going to square root both the numerator and denominator to get 3 over 2. So that's the ratio, 3 over 2. So we have 168 for our volume here, right? We're going to multiply that by 3 over 2. The problem is this is in the third dimension, so this is going to be to the power of 3. So just type this in, 168 times our ratio of 3/2, and that's going to be to the power of 3. And I get 567. Our units here are going to be meters cubed because we are in volume, which is the third dimension. So 567 for number 14, 567. And the last one, kind of the same thing. We're going to set up this ratio. We're going to say 750 over 6. We're going to reduce that. So 750 over 6 reduces to 125 over nothing, right? Over just 1, I guess. So that is the correct answer, except that this was in volume land, which means we have to cube root it to get back to just the side length. So cube root, and this is going to be 5 over 1. If you don't trust me, you can do the cube root on your calculator of 125, and you can see that's 5. So now we just take our surface area. Our surface area is 8, and multiply by 5 over 1. But both of those need to be in area land, which means we need to square it. So if I say 8 times 5 squared, we get our final answer, which is 200. The units here are going to be in meters squared, not meters cubed. 200 meters squared, 200 meters squared, and that concludes the practice test. Thanks for watching.